today we're going to discuss about natural phenomena involving light, like formation of a rainbow and why are sunsets red. First, let's discuss the formation of a rainbow. A rainbow is a spectacular display of colors. It is produced by refraction, reflection, and dispersion of light. When sunlight strikes droplet of water, each drop acts as a prism, separating sun into colors. When sunlight strikes the water droplet at its front surface at A, the light is both refracted and dispersed. The violet light is the most bent, while the red light is the least. When sunlight strikes at the back surface of the droplet, red light is reflected at R and violet is reflected at V, returning to the front surface. When the rays leave the droplet, both rays are again refracted as they move from water to air. The angle formed between the incident sunlight and the refracted violet ray is 40 degrees. The angle between the sunlight and the refracted red ray is 42 degrees. The other colors are formed by droplets between these angles. A rainbow takes the format of an arc because the observer sees the colored rays refracted from the droplets in all directions at angles between 40 to 42 degrees. So now we're going to discuss about why are sunsets red. The light that is not scattered is able to pass through our atmosphere and reach our eyes in a non-interrupted path. The lower frequencies of sunlight, like Roy or red, orange, and yellow, tend to reach our eyes as we sight directly at the sun during midday. While sunlight consists of the entire range of frequencies of visible light, not all frequencies are equally intense. In fact, sunlight tends to be the most rich with yellow light frequencies. For these reasons, the sun appears yellow during midday due to the direct passage of dominant amounts of yellow frequencies through our atmosphere and to our eyes. The appearance of the sun changes with the time of the day. While it may be yellow during midday, it is often found to be gradually turned color as it approaches sunset. This can be explained by light scattering. As the sun approaches the horizon line, sunlight must traverse a greater distance through our atmosphere. As the path that sunlight takes through our atmosphere increases in length, Roy G. Biv, or red, orange, yellow, green, blue, indigo, violet, encounters more and more atmospheric particles. This results in the scattering of greater and greater amounts of yellow light. During sunset hours, the light passing through our atmosphere to our eyes tends to be the most concentrated with red and orange frequencies of light. For this reason, the sunset have a reddish orange hue. The effect of a red sunset becomes more pronounced if the atmosphere contains more and more particles. The presence of sulfur aerosols in our atmosphere contributes to some magnificent sunsets. In conclusion, rainbow is formed through reflection, refraction, and dispersion of light. And sunsets are red because near sunset times or hour, light travels longer distances with more air and dust in the atmosphere Thus, most of the blue light is absorbed before it reaches you. Red light, which has the longest wavelength, is the most predominant color left when the light from the sun reaches the eye. Hence, the sunset appears red. That's all for today's video.